Okay, we're working on the balancing of these flywheels here. These are for the XLCR bike with the thunderheads on it. So this was previously balanced by somebody else. So for some reason they drilled the holes on the outside of the wheels instead of the inside of the wheels here, like I do it. So you gotta be careful about cutting out your timing marks when you do stuff like that. This here is about the weight that it's at right now. You can see how it's pretty far off how I do it. The weight's about halfway up the flywheel, so that's about what they were balanced at. Obviously the wheel should be would not move if it's perfectly balanced, but it's heavy on the bottom here. So the flywheel's heavier here on the bottom down here. It's not balanced evenly. Usually if you're doing a dynamic balance, it'll be off by like something like over in this area. Not 90 degrees like this one is. So here's the other wheel over here. So it should be drilled through here, but it's not. So they drilled all through here, get a weight over here. It says it's not good to drill over on this side because it's like where all your timing marks are, so you don't want to be cutting through those. So anyway, so right now I've got this weight right here. So to find out what this is, I'll go ahead and take this out. Here's my stock Harley weight over here, which is 1106. That's what I do on a stock ironhead sportster motor. And that fell out. Okay. So here's a built-up weight. We just add weight until we get what we need. So I had that many washers. We just use different washers and assortment over here to make it work. Okay, so this is how much this one is. This is how much I normally use here. So we'll take these over here. Button away. Okay, here's what we do over here. I've already pre-laid this all out. Here's my balancing beam mechanism I use for doing my rods. So you can see how it fluctuates depending on how much I move the bench here in my leg. That's how accurate it is. So basically I got a self-aligning bearing here, so it allows the rod to flop around. We got ball bearings here, which allows it to rotate. And then we're on a floating ball mechanism under here, so this whole thing can jiggle. So all this stuff here is free to jiggle around. And I got my scale balanced, or not balanced, but level on the workbench. I shimmed it up until it's level. So when you do all this, you get very accurate weights. So this here just basically just slides on and off like this. So this is self-aligning bearings, so there's no drag on that. It's free to rotate in the bushing here. And these are obviously free to rotate here. Now this is not self-aligning here because if it was, the rod would just flop. It would just go like this. So you have to have something to hold it, but this is all free to float here. See, comes off too if you're not careful. So I've tried hanging strings and all kinds of dual scales and all kinds of crap, but this works pretty accurate. These are the numbers I was getting here on the rod. This is the big end, this is the small end. This one we just did 278. So I got 277.8, 277.9, and 278.0. The small end I was varying by 1/10. I took that number out to that small number, and it came out the same weight as what the rod weighs when you measure just the weight, the rod on there by itself. Usually they're, if you're within 5 grams, you're doing pretty damn close. But I'm holding 1 gram accuracy now. The big end we were floating about 1.5 was my float number. So I went up using this one here on the big end and this one on the small end. So it's floating around a little bit depending on how the scaling was measuring. The scale fluctuates a lot just on itself, so if you just go like this on the bench, it changes, and it'll change by 2/10 just because it feels like it. It's an accurate scale, but it's not, and the accuracy is not high enough for me. Alright, so basically we got the, we measured up our crank pin here with the nuts, we got our cages with the bearings. I did it without the plastic, obviously. We got the wrist pins, the clips the rings and all that are on the pistons here. So these are what the CR domes look like. Or not CR, but the Thunderhead domes. So this is the numbers we came up with here. You run it all the way down. So you got your total piston weight, your wrist pin into the weight, which is this half the rod here. For both of them, you add that up, you get one number. Here's your crank pin weight, bearing weight. This is the total weight of the connecting rods, both of them. You add all that up. You multiply it by the balance factor. This one we're going to do a smooth balance on this one for lower RPM, low and mid-range, so something more in the 3,000 to 4,000 area. So I went with a 56% instead of my normal 60 like I do. This is your reciprocating weight here. After you multiply this number here by your percentage, you get this number here. Now that's a percentage of the reciprocating weight, which is your piston weight and the up part of the rod. That's what you're changing. The rotating weight stays the same because that never changes, because it rotates with the flywheels. So here's what your reciprocating total is. This is your rotating weight here, which is all your big end weight, this end, crank pin bearings. So that's what that is. You add those two together, you come up with that number, you divide it by 2 because you do each wheel half separate, and that comes up with this total here. So my normal sportster weight's 1106, and it wants me to do 1189, basically 1190, which is pretty close to a big twin weight. Big twin weight's like 1220 as I recall, something in that area. So these pistons here are pretty heavy, and that's showing up right here in our weight here. If I use 60%, it would be 1215. If I use 52%, which would be a very low RPM stock type balance, it's more of an automotive type thing, it'd be 1163. So I don't know what this is, so let's find out. Take this off. Should be alright with that being there. We zero our scale here. Bounce it. Comes back to 0. Let's see what they had it at. So they had it at 997. And I'm showing that I need 1190. That is way the hell off. So even at 52%, which would be a very low number, it'd be 1163.7. So that would be closer to 1164 than 1163. Yeah, we're at 997. .3. So this was 997.3. Oh, it's up to 4 now. Can't decide if it wants that 10th in there or not. See, the scales vary. Until I start seeing a bunch of marks here, I don't believe it. So see, now it wants to go with 997.4. And we'll go with that. Cross that out. That ought to confuse everybody. Alright, so I've already double checked my numbers over here because these numbers came up pretty high and everything looks like it's the same. Check our rod weights here. We'll do a quick double check. So we're at 470 and something. Looks like that's coming in the same number, 7/10. It's like around 615, 8. Yep, we're good. We're at 6 right now. It's close enough for that what we're getting. I already measured the piston weights again. We were right in the same ballpark, 908 and change. 908.3, so that's close enough. So all the numbers appear to be coming in the same numbers. So this is the correct number that we should be at. These are the other numbers that we might go with. So I'll call up the customer and see what he wants to do. This number here is obviously bogus, and we already saw the flywheel was bogus on how it was measured. And like I said, this is my stock Sportster weight here, which is lighter than this by quite a bit. That'd be down there probably about 45%, which is way less than we use. So let's go see how accurate these other flywheels are over here. So we already know what this one is. This is our right side flywheel. So I'm going to go ahead and take this shaft out of here. I'm going to swap it over here and we'll be back. Okay, here's the other flywheel in here. So you can see how the weight's a little bit higher up than the other side was. And you put the 10 gram weight on here, up here on top. You see that kind of balances out where it was. This is 997, so that makes it 1007. So that's the same thing, it's 90 degrees off on the balance thing, on the factor. So it's still off by quite a bit. So, same thing. So basically this is my heavy weight over here, which is a 1201 weight. That's what I used to use on my flatted race bike. So let me go ahead and see what this is here. Get an idea how much extra weight we're going to have to add here. Basically all these holes over here are going to get filled in, I think. It's fun to do with one hand. Okay, this one just slips in. There we go. So you can see how far off that is. Let's see, we need to add a little extra weight. Get a reference point here. Need a lot more than that. Need something heavy. Yeah, that was enough weight. Alright, 2 of those is too many. So I just kind of for a reference, kind of about how far things are off. Just screwing around here. That's all this is. Yeah, we're close to that. There we go. That's about how far off we are. Thing's way off center weight. It wants to flop over real bad. So basically we take all this metal here, we put it back in these holes, and we'll probably come in pretty close. Like most of these jobs, undo what was done, and you'll probably be pretty close. So now this is for a higher RPM balance. This is probably about a 59% balance factor with this heavier weight. Let's call it 58%. So not quite what this customer's after. We're going a little bit less than that. So, all right. Well, that way you get an idea what we're doing. So that's how you determine how far off these things are. And we'll go ahead and figure out what we're going to do for weight, and we'll come back and show you us actually balancing these things. And more than likely, I'm going to just start filling all these holes up, make a bunch of plugs and fill them up. Or I might tap them and just put lead in there. We'll make a decision. So there you go for now. Okay, just for a frame of reference, here's a stock Sportster flywheel that hasn't been modified any. These things sometimes have 2 holes, 3 holes, or 4 holes, but never more than that. Most of the time 3 is the most common, like this one is. This one here is a 57 casting that was done up in 72 time frame because it has a brass washer up in there, you can't see it. So this is my Sportster weight here. This is just my universal one I use. So with this weight here, it's a little bit heavier than what the Flywheel is balanced for. That's how close the Sportster is though. This is a performance balance factor here. So you can see how it's about right like there. If you go 180 across, you can see how much weight's actually out of it. That's how much you gotta do it. So when you drill these out, you gotta drill on this side here a little bit. That's what you want up doing. It's the same basic thing. If you basically put the weight back in here that they took out, the wheels are pretty much casted the way they're supposed to be. So Harley had the right idea on it, but they missed it by a little bit. But these are pretty close. But this 1,100 gram weight, and that one we just did over here was 1,000 grams, so it's way the hell off. So anyway, that's just a reference. You know, that's why the Sportsters don't have to really be balanced. They're fairly close, but if you want them right, you can see the air that's in them right now. So there you go.